Welcome back to another episode of Python programming from beginner to programmer. So in this episode, we will begin our exploration into SQL, the structured query language. This is by no means a new kid on the block. It has been in use since decades ago, and was designed specifically to store data, and it's widely successful in being deployed and used in commercial, business, scientific, military, mathematical kind of situations, and even personal situations where we need to store data and retrieve data. Um, it's very successful because we like to be able to store data, retrieve data, and do it quickly, and yet do it adaptively. And that means as our business grows, we like to add more data fields. Can we do that, in a very organized way, and yet logical, and yet efficient? So I'm adding more and more desired features, and some of them are really contradicting, right? So we want it to be fast, we want it to be vast in its data storage capability, and so on and so forth. So having decades of developmental time, structured query language has also evolved to become able to really deliver all these rather contradicting requirements. And it's not surprising that we also find SQL being used in its various flavors and varieties and by different vendors in websites where the websites might ask you create a new account, what's your password. Now, where do you think they store all these bits and little bits, packets of information? Well, exactly in databases. And anyone whom you talk to who mentions database, if you guess it is in some flavor or version of SQL, you are very, very likely to be right. So let's begin our discussion in two different sections, let me put it this way. So the first section is to really understand what is SQL. Now, although we are learning Python programming language, SQL itself is also a programming and data access language for SQL servers. So when we need to query or update a database, we need to speak SQL. Then the database understands what we want and can help us achieve our storage desires. Okay, so we'll begin by first of all understanding why. Why do we need a long-term storage? Because we also learned earlier on in the videos how to read and write from files. We can also do, for example, file access and design our storage, design our file formats. We can do that. Why do we need SQL, right? And also, we want to learn about some lingos, SQL lingos. How does SQL look at the world of data? How does it organize, right? What's the lingo that it speaks? Then we look at how we can use SQL, speak SQL to create, delete databases, tables, all right? And then inserting, updating data, deleting data, the standard usual operating commands that are necessary. And then there are of course along the ways there are some special situations that we need to be aware of, and we'll see how to go about those. Then retrieving data in its variety of ways, and then cross-referencing tables. That means we are going to sort of conceptually link different tables together. We'll talk more about that. And finally, a little bit on how we apply SQL in real world. So the way SQL looks at the data world, right? So it's quite direct actually, because first of all, remember SQL was started decades ago when computers were slow, and we have different grades of computers. The more expensive, high memory, high storage, and by the way, high storage means 500 megabytes, something like that, or 2 gigabytes, and this high storage. So we have powerful servers that have huge capacity in storage and processing capabilities. And we also have many terminals or workstations or computer clients that are kind of smaller in its ability to process and slower and having lower amount of memory and hard disk. So if imagine you are running a corporate business that has a lot of customers and a lot of transactions and a lot of history, you will not be able to process quickly, right, with a slow computer. And even if you can, you have to wait for a long time. That is not going to make much sense because we use computers to achieve speed and efficiency. So what was happening in those days, basically, and even now, because the faster computers will have, you know, petabytes of storage and maybe 1,000 processors running, and that is much way more powerful and faster and bigger than one Intel CPU running um, 3 GB of storage and 4 TB of hard disk space. Right. So the scales are enlarged accordingly. We still have this sense of powerful server versus client. So I'm going to use server and client. So our workstation, our PC, our notebook, our laptop, mostly are considered clients, right? So you will, so in this world, the client speaks to the server via the network. Yeah, via TCP/IP network. And in those days, we have IBM networks, HP networks, and various kinds of networks by different vendors. But by and large, nowadays, we just think about internet. So we connect via internet to a remote computer. All right, this is important. A remote computer separate from your own workstation that you are running the query, the required data for access. So the idea is it's separate. There's a storage for data. There's a processing need for parts of the data, right? So imagine a headquarters, international company with hundreds of branches in hundreds of countries, and a branch, say in Singapore, is trying to access headquarters file in New York. So that access will certainly be done via network. And when we access, we certainly are not downloading all the data from various parts of the world, Africa, Europe, China, and Japan, and various countries. We're not going to do that. We are basically processing, querying customers from local, right? So based on Singapore's context, and we are trying to query the headquarters for that parcel, small subset of customers who are, let's say, linked to Singapore. So in that sense, we don't want to download the whole petabytes of information. We only want to say, hey, you know what, database, you're trying to speak to the computer. I want those information related to Singapore and so on. So how do we speak such language? And SQL was born to address this need. So we will say something like, later on we will learn, but we will say something like, select customer name, customer address from database transactions where customers address or country of residence equals to Singapore. And that makes sense, right? So it contains all the necessary information to localize customers to those who are residing in Singapore. And then back comes this, I don't know, a few kilobytes or a few megabytes of information. And certainly it's much more efficient and applicable to our current need to gain access to those data, isn't it? We don't download the whole bunch, then to filter off almost 99% of the information. That would be quite a waste of the bandwidth. But more importantly, it's so sluggishly slow that your customer is going to be screaming, "What are you doing?" Right? Okay, so important thing is the idea is to allow separation of the huge storage, right? Huge storage of server of data, and that is the database in the server computer versus the workstation that is trying to access, and in most cases is to access a small portion, a few percent or 10% of the entire information in the database. So this will be how almost all SQL versions, MySQL, MS SQL from Microsoft, Oracle's SQL, IBM's SQL DB2, Postgres SQL, Mongo, MS Access, Microsoft Access is also a sort of a miniature version that supports SQL. You can actually type the same SQL query into Microsoft Access and it will be able to understand. So it's a language. It's also a way of organizing data, right? So this is the the DNA how SQL was born and how it looks at the world. So pandas, on the other hand, which we have learned earlier on in data analytics section, is a very memory resident kind of data access support function, right? So a suite of functions in a library that basically allows us to sort of manipulate the data frames that pandas creates. So that is resident in memory, and then we gain access. So there is some overlap in terms of thinking because it's read data, write data. But as we can see in this little illustration here, pandas is over here. You can deal with pandas via Python program, and Python program, or rather SQL, is never used in between them, but rather towards database. Now for SQL, even though I mentioned that one of the main driving desire is to have core bulk of the data stored in a powerful server that is backed up frequently. So even if you have power failure in the branches, entire power failure, entire power hard disk corruption, you still have very decent backup from the server. And so those are the quite major considerations, but it doesn't prevent SQL from being run in the same computer, right, as your client. So it doesn't say, oh, since you're on the same computer, I cannot run. It can. It can. So there are many cases also where we do this. For example, in web servers, the web server is running a blog, website or your company's website, and it allows customers who are looking at the website to create new account, and then it's going to have another database together with the web server, right? So the web server will query the database directly, and perhaps when the business becomes much better, you have millions of users, and the computer is beginning to feel a bit slow. You might want to move the database to another computer, and that's where the benefit comes. When you scale and expand your business and move the database to another computer, your code, your programs, your website doesn't have to change. Instead of pointing at your own IP address or IP name, you just point to the new IP name. Finish. Very simple. The rest of the queries and all the commands are the same. So that's the beauty of it. SQL handles all these.